All right, welcome back to another lesson, and I would just start with, we're going to be talking about complementary and supplementary angles, and this video is to augment or to work with our lesson for the day. So if you're not getting every answer that you're looking for in complementary and supplementary angles, understand that this is intended to work with our instruction, our activity for the day, or to replace instruction in case you weren't in class. So as we talk about complementary and supplementary angles, we're extending what we just learned about linear pairs and vertical angles, and we're going to go into how are angle relationships used to solve for angle measures. So as we learned before, linear pairs, if two angles form a linear pair, then they are supplementary. And supplementary angles are two angles whose measure have a sum of 180 degrees. Okay, and then so looking at this, we can see that we have, in this first example right here, we can see that we have these two angles that are a linear pair, and we have angle ACD, and then we also have angle, DCB. They would be a linear pair, and they form 180 degrees. So therefore, if those two angles added together equal 180 degrees, that means that those angles are supplementary. So let's see, linear pairs, supplementary angles. Now with that, I will say that those two are linear pairs. They have an adjacent side, and they are adjacent angles, or have a side common, and they're adjacent angles, and they are supplementary. But our angles do not actually have to be adjacent or touching in order to be supplementary. It is two angles that when we add them together form 180 degrees. So here we have angle UTS, that is 60 degrees, and then we have VWX, which is 120 degrees. So those two angles added together, when I add them together, they are going to equal 180 degrees. So those two angles too are going to be supplementary. Again, just focusing on that, it doesn't matter that they are adjacent, have a common side. It's just when two angles sum to 180 degrees. Complementary angles, on the other hand, are two angles whose measure have a sum of 90 degrees. Okay, now just like on my supplementary angles, they don't have to be touching, they don't have to be adjacent to each other, they don't have to have that common side. But here we can see that we have RST is a right triangle, and then I do have this common side, so I do have that. I have angle RSU plus angle UST equals that 90 degree angle. And then of course here I do have angle GHJ, and I have angle NML, and those added together will also equal 90 degrees, showing that they don't have to touch. And I will say that if you ever forget complementary and supplementary, well, I will just say that they're alphabetical, right? C comes before S, 90 comes before 180, so complementary is 90, supplementary is going to be 180. So looking at example number 1, find the angle measures. All right, so what do we know here? We know that to look at this, if this angle is 90 degrees, I know that here is a straight line, and a straight line is going to make 180 degrees. So I know that this angle and this angle added together should also be 90 degrees. And I could simply say that angle 1 is going to be 90 degrees minus 70, which is going to be 20 degrees. I can also see here, what do I know? I can look at this and say that I have two vertical angles, or two lines intersecting, forming a vertical angle, and that if this angle right here is 70 degrees right here, then its opposite vertical angle is going to be 70 degrees. Filling those out. Now let's see, I know that this right here again is a linear pair, so I know that angle 4 is going to be 180 degrees minus 70 degrees, which is going to be 110 degrees. Now I am taking some shortcuts here, okay, admittedly so. And I say that because I mentioned before writing out the equation. So I know that angle 3 was 70 degrees, and I know that angle 3 plus angle 4 is going to be equal to 180 degrees. And if angle 3 is equal to 70 degrees plus angle 4, it's going to be equal to 180 degrees. So therefore, if I subtract 70 from both sides, angle 4 is going to be equal to 110 degrees. Okay, that's doing the math, that's showing my work. We're going to get to the point where, yeah, you can do that in your head, but we do have to practice enough to where it becomes second nature. And the same thing goes over here, that, you know, again, I guess angle 1 plus 70 degrees is equal to 90. So I subtracted 70 from both sides, and angle 1 is equal to 20 degrees, which is what I did there very quickly. And then I did throw out there that angle 2 was 90 degrees because guess what? It was a right angle. So there we go. We went ahead and filled in some of those and find those missing angle measures based on what we know about vertical angles, what we're learning about complementary and supplementary angles. Continuing on with example number 2, so we have these two angles, and it tells me that angle QRT, this angle, and angle LMN, this angle, together are complements. So I know then that the angle QRT and angle LMN equal 90 degrees because complementary angles equal 90 degrees. And it says find the measurement of QRT. Well, before I can get to the measurement, I need to figure out what in the heck that variable is going to be equal to. So I can go ahead and do some substitution. Again, I created the equation using my definition. Now I'm going to do some substitution. And so QRT is going to be 5x. LMN is going to be 9x plus 20. That is going to equal 90 degrees. And I combine like terms, and I end up having 14x plus 20 because 5 plus 9 is going to be 14. Okay. And then I'm going to continue to combine up like terms by moving 20 to the other side by subtracting it. What I subtract from one side, I must subtract from the other. So 20 minus 20 becomes 0. So I have 14x is going to be equal to 70. Divide both sides by 14. And I believe x is going to be equal to 5. Now, they didn't ask me for x. They asked me to find out what in the heck QRT is. So QRT is going to be 5x. So 5 times 5 is 25 degrees. QRT is 25 degrees. There you go. Remember, creating that equation using our definition, doing some substitution, combining like terms, and solving at that point in time. Moving on to the next one here, congruent complements theorem. Okay, well, if two angles are complements of the same angle or of congruent angles, then those two angles are going to be congruent. So let's see here, going to be congruent. What do we have here? It says if angle 1 and 2 are complements, okay, so I know angle 1 plus angle 2 equal 90 degrees, and angle 3 and 2 are complements, so I know that angle 2 plus angle 3 equal 90 degrees. Then angle 1 and angle 3, what? I'm going to tell you right now, they're congruent based on my definition up here, right? They're congruent, but if we do it mathematically, I know that angle 1 and angle 2 equal 90. I know angle 2 and angle 3 equal 90. So back in that day of doing algebra, when we would do substitution, I'm going to substitute this for this because we know that that's what it equals, right? So in doing so, I know that angle 1 plus angle 2 equals angle 2 plus angle 3. Great. subtract angle 2 from one side because I want to combine like terms, right? If I subtract it from one side, I must subtract it from the other. There you go. That cancels out. And it turns out the only thing that's left is angle 1 is equal to angle 3. And if those two angles are equal, then by Joe, they are going to be congruent. And that is doing it algebraically. Now, doing that same example here, if angle 4 and angle 5 are complements, and angle 6 and angle 7 are complements, then angle 5 is angle 5 is congruent to 6, then angle 4 is congruent to, well, this angle equals this angle, and if 4 plus 5 is 90, 6 plus 7 is 90, then 4 must equal 7. So angle 4 is congruent to angle 7. And we can do the same thing. We can say angle 4 plus angle 5 equals 90. I have angle 6 plus angle 7 equals 90. And then angle 6 equals angle 5, so I could substitute that out, and I could say that angle 4 plus angle 6 equals 90, since these two things are interchangeable because they are congruent right here. And then again, right now I have this and this, which is the same thing that we just did right there. But anyway, understanding. So let's see here, moving on. Congruent supplemental angles. Now this is going to be the same thing. If two angles are supplements of the same angle or congruent angles, then the two angles are going to be, they are going to also be congruent. So here we have, in that same reference, that if angle 1 and angle 2 are supplements, so angle 1 plus angle 2 equal 180, and then angle 3 plus angle 2 equal 180, then we know angle 1 and angle 2, or angle 1 and angle 3. Well, let's do the inverse. If we try to isolate, let's do this a little bit differently now. Let's try to isolate those two angles. And we find out that if we subtract angle 2 from both sides, we have angle 1 is equal to 180 degrees minus angle 2. And if we do the same thing over here to isolate angle 3, we have angle 2, subtract angle 2 from both sides, I have angle 3 is equal to 180 degrees minus angle 2. And if you notice, angle 1 and angle 2 equal the same thing. So there we go. We know that they are going to be congruent. And that's one thing that if we remember the definition, we don't have to keep doing the math. So that's why learning our definitions are very important. And then here, if angle 4 and 5 total 180, if angle 6 and 7 total 180, and angle 5 and angle 6 are congruent, that makes angle 4 congruent to angle 7. So there you go. 4 is congruent to angle 7. Now we're going to start doing some algebra, using some algebra here to do some things. Let's see here. I know in example 7 it says angle R and angle S are complementary angles, and then they go on to tell me what these angles equal. Okay, well, I know that complementary is going to be 90 degrees, so I know that angle R plus angle S equals 90 degrees. And now I can do some substitution because they want me to find out what the heck is the measurement of R. So looking here, angle R is going to be 12x minus 3 plus 7x minus 2 is going to be equal to 90 degrees. Combining like terms now, my variables can be combined, my numbers can be combined, so I end up with 19x minus 5 is equal to 90. Add 5 to both sides, and then 19x equals 95, divide both sides by 19, and I find out that x is going to be equal to 5. And if I know that x is equal to 5, I can substitute that in right here. Okay? What is the measurement of r? Well, r is equal to 12 times x minus 3, equal r equals, and we know that x is 5, so that is going to equal 60 minus 3, which is 57 degrees. And that is doing it with complementary angles. Now, if we're going to do it with supplementary angles, we're going to do the same stuff. So look at example number 8. It says angle P and angle Q are supplementary angles. So that means that angle P plus angle Q equal 180 degrees by the definition of supplementary angles. Then it tells me that the measurement of P is something, the measurement of Q is something, and then it says find Q. Well, we need to, in order to find Q, we solve for that variable. So let's do some substitution. P is 4x plus 1. Angle Q is 9x minus 3, and they combined equal 180 degrees. Combining my variables, 9 plus 4 is going to be 13x. We have a minus 3 and a positive 1, which is going to be minus 2 equals 180 degrees. Go ahead and do my inverse operations to isolate my variable. I'm going to add 2 to both sides. And I have 13x is going to be equal to 182. Divide both sides by 13, and x is going to equal 14. Right there. X turns out to equal 14. 182 divided by 13 is 14. Now, the angle Q thing is going to be 9x minus 3, and we said x is 14. So that is going to equal, 126 minus 3, which is going to give me 123 degrees. There you go. That is the measurement of angle Q. And there you go. Starting off with our definition, knowing that these two angles added together equal 180. We did some substitution. We combined like terms. We did some inverse operations. We divided that last step by the coefficient. Found out that x equals a number. We were able to substitute that value back in here and find the measurement of x. So there you have it. As we go on and we are working with these rules that we're learning, creating these word problems, I'm hoping that it's not getting any more difficult each day because we are doing the same thing over and over again, just with a new definition.